Okay, so what I'm going to talk to today is, in some ways, it's a little bit more introductory than some of the stuff that Rory talked about yesterday. Because Rory yesterday, for those who were in that session, can I get a show of hands? Those who were at Rory's session yesterday?
What was the session?
It was a SNOMED session. Okay, so a few. Okay, that's good. There's a little bit of overlap with what I'm talking about. Rory was talking about how you use SNOMED with FHIR Terminology. I'm going to take a step back and talk about the FHIR Terminology Service API. A couple of the examples that I'm going to use will incorporate SNOMED. I think there might be an example that has LOINC in it. I've got a couple of examples that use some FHIR code systems that they've defined. What I'm trying to cover today is not how you use an individual coding system using FHIR. It's how the Terminology Service API helps you do certain things when you're trying to build different parts of software or use FHIR to do things in healthcare. So what I'm going to do is come at it from a use case driven perspective. So if you're trying to do data entry, or you're trying to do analytics, or you're building a server, or things like that. So why are we interested in terminology? Terminology is really important in FHIR because it's the basis of shared meaning. So when we exchange these resources between different places in the system, the structure definitions that FHIR gives you, they give you the skeletons of the structure, but the real meaning lives in the leaves or the meat on those bones. And that's where terminology is. So the codes that you've got in the different elements in your FHIR resources, that's where the shared meaning is between systems. And FHIR Terminology has done a really good job of giving us a single way of talking about terminology across a whole bunch of different code systems in a way that really helps us in practical systems. In a large integrated system, it gives us a way of having a single reference point for terminology if we want to, which is really valuable for interoperability. And it also makes it possible to externalize terminology so that rather than having terminology capabilities integrated in or built into each different system, we can, if we choose to, have an externalized terminology service that is a single source of truth for terminology in our larger system, if we choose to do that. Just as a bit of context as to why I'm up here talking about this, I'm from CSIRO, as the shirt says. We make a terminology product called OntoServer that is one of these servers. None of my examples talk about our product specifically, so it applies equal to, hopefully, any good terminology server that's out there in the market. So these are some of the use cases that I'm going to talk about today. So if you're doing data entry, then terminology and terminology services are interesting because they allow you to very quickly find the right code, whether it's a clinician entering data or even a patient entering data or an analyst downstream entering data. Terminology APIs give you a way of searching for a specific code or a specific concept. If you're doing validation of data, so maybe there's been a whole bunch of data gathered, perhaps it's coded data, perhaps it's even plain text data, then the Terminology Services APIs give you ways of analysing that data and working out whether that code, if it's a code, is appropriate for the context in which it's being entered. So if you've got a diagnosis field and you've got sort of common cold, broken leg, and then aspirin, then you can very quickly determine which of those are actually appropriate codes for that field. If you're doing display and understanding, so you just want to browse the code system and see what's in there and see what might be appropriate, perhaps you're preparing a set of codes for later analysis, then the Terminology Service APIs give you ways of exploring a code system, looking at the details of an individual code or looking at a group of codes and how they interrelate. If you're doing mapping work, so perhaps you need to convert your clinical codes across to a billing code system, or you need to do migration of legacy coded data across to more modern code set, then the FHIR Terminology Service API gives you ways of doing mapping, both in terms of defining maps and then in executing them to actually translate a code through a map. If you're doing analytics, so you've got a whole bunch of coded data and you want to get a holistic view of what it's trying to tell you, then the FHIR Terminology Services APIs can really help you with that. You can build value sets which represent categories that you're interested in, and then group your codes into these categories to try and group the resources that you're dealing with. If you're authoring terminology, so perhaps you've got a local proprietary code system, or you've got a specific value set that you need for a field in your, for data entry in your system, then FHIR has a bit of a story for authoring. It doesn't go into the sort of deep authoring that you might need, for example, for authoring SNOMED CT concepts or authoring ICD or LOINC things, but it has a story for authoring code systems, which can be very powerful. And finally, if you're building a FHIR server, a more general purpose FHIR server, then there are ways that you can integrate with the terminology service that can make your server much more powerful, particularly regarding terminology-aware search or validation. So I'll talk to those a little bit as well. So just as a brief overview, these are the three, it's 5 boxes, but it's 3 different concepts that are the most important in FHIR terminology. So I've put little N's on the diagram because terminology is a part of the FHIR spec that has gone normative, or large parts of it have gone normative in R4. So the code system and value set resources are now normative, as well as their operations. The concept map resource is not normative, so that's the one that perhaps isn't quite as solid, although I think it's still maturity 3, so it's still getting there as well. So the code system resource is the starting point for terminology. This defines some set of concepts with some sort of coherent meaning. That could be large sort of standard code systems like SNOMED CT, LOINC, CPT, ICD, etc., RxNorm. Or it could be small, very specific purpose code systems like administrative gender in FHIR, or medication statement status, or it could be proprietary things that are specific to some healthcare setting. So it could be the set of departments that exist in a given healthcare provider. And the concepts that we define in a code system can have a whole bunch of metadata that are shared across the code system, but then they can also define different properties that exist on those concepts. So in a terminology like SNOMED CT, that's very rich. There's an awful lot of properties. In LOINC, you've got the different parts that exist in the LOINC terms. And then you can associate different properties depending on what your use case is. So I've got an example later on where I've got a little code system of the jurisdictions in Australia, and I've got the capital of each jurisdiction as a property. And by defining these properties on the code system, we can then filter on them later on, so that when we want to build up a value set, we can use those properties to narrow down the set of codes that we're interested in for some specific context. And that is the second resource, is the value set resource. So once we've got these code systems, the next thing we want to do is we want to gather some set of concepts from those code systems, whether it's from a single code system or in some cases across multiple code systems, that are useful for some purpose that we have, so some context that we're using. And value set resources are a way of defining the way that those selections of codes, whether it is as a list of codes or whether it's according to some rules, perhaps based on the properties of the concepts, or perhaps by including other value sets. So we can build up these value sets for a specific context. And then the third resource, which is the one that's not yet normative, it's a concept map. And a concept map allows you to express a relationship between the codes in one value set and the codes in another value set. So that might be equivalence type of relationships. If you've got data that's being entered in one code system and you want to map that across to normalize it into another code system, or it might be for other purposes. You can use concept maps for aggregation to say that these codes over in this value set all map up to this higher level category, or other purposes. So concept maps are a very general purpose tool for mapping between value sets. Okay, so I've put this up here just in case, if anyone's not familiar with FHIR. The terminology resources work largely the same way as the other resources. They support the SCRUD operations, so the search, create, read, update and delete, with search parameters for search and so on. That isn't any different from the rest of FHIR. Perhaps slightly different from the rest of FHIR. Terminology is a part of the FHIR spec with quite a heavy reliance on operations. So most of what I'm going to talk about today is actually the operations that are defined on the terminology resources. I will have a little bit of a look later on at authoring resources as well, but mostly I'll be talking about the operations. And there are different ways of calling operations. You can either call get if it's an idempotent, so if it has no side effects, then you can use HTTP get, and for all operations, whether they're idempotent or not, you can use post as well. Okay, so the first use case I'm interested in then is data entry. So we need in some way to come up with some interface for a clinician or someone else involved in the healthcare process to enter data. And what we need to do for that in terms of the FHIR Terminology Service API is, first of all, we need to identify which code systems we're interested in. So perhaps we want the clinicians to enter SNOMED CT terms, perhaps we've got a small FHIR code system. Ideally, we want to be choosing standardized ones, because if we're using standardized code systems, it makes interoperability much easier down the track, but that's not always a choice that's completely open to us. Once we've chosen our code systems, then we need to identify our value sets. Once again, hopefully we're able to pick some off the shelf that exist. So perhaps we use SNOMED CT reference sets, or perhaps we use value sets from the FHIR spec, or from an implementation guide that we're basing our implementation on, or perhaps we need to define our own, and I'll get to how we define value sets later on. Once we've then got the value sets, then we choose how to represent that. So if we've got a very small value set, such as administrative gender or marital status or something with only a few values, then we could use a radio buttons or a drop-down list. On the other hand, if we're doing something like a diagnosis or a medication where there's an awful lot of choice, then we're probably more likely to look at something like a type ahead or a search interface. And if your terminology API is good enough, then type ahead will work fine if the search is fast enough. Otherwise, you can use a search style interface. So the operation that we're interested in this case, or the most interesting operation for data entry, is expand. So expand takes the definition of a value set, and it gives you all of the codes that are then a member of that value set. Now, if you've defined your value set as a list of codes, this is obviously a very simple operation. It just says, well, it's the same as the ones you defined it as. On the other hand, if you've defined your value set in terms of rules, whether they're based on the properties or based on including other value sets, then it can be a bit more complex, right up to the point of being very complex. If you've used things like the expression constraint language on SNOMED CT, you can have very complex value sets at times. So to use expand, we pass it a value set. Usually we identify that using the URL of the value set and potentially the version as well. But we can also do an instance level thing where we point at a specific value set on the server and we say expand that one. And then when we invoke that, it comes back with another value set as a result, and the resulting value set will have an expansion element in it, and that will have all the codes that match the expansion request that you sent the server. So there's a whole bunch of parameters that you can use on expand. Filter is a text filter that you can pass it that says only show me codes in the value set that match this text filter. Now, exactly what that means is a little bit dependent on the server. There's no rule that says the server must do substring matching or must do prefix matching, but the server will give its best effort. You can also pass it a count and an offset. So this allows you to do paging on the expansion. So you can say, give me the first 10 elements, or give me 10 elements starting at element 50. So you can work your way through the expansion if it's large. You can choose to include designations in the expansion. So designations in a value set or in a code system as well. Things like synonyms, they can be things like translations, they can be things like definitions of the code. So we can ask the expansion to return those with the expansion if we choose to. Otherwise, the server's at liberty as to whether it will or won't include designations in the result. We can also ask it to either include or not include the definition of the value set. So that logical definition with the filters and rules that define which codes should be in there. And then a few other things that basically allow us to control the structure that comes back of the expansion. So as a couple of examples of this, this is a simple expand request of the administrative gender value set, which is a very small value set. It's only got 4 codes in it. They all come from the same code system. So we can send that just as a GET request. We can tell it we want JSON back. We could equally tell it we want XML back. And we get back a value set resource with an expansion element. So the expansion both tells us what the parameters were that were given to the expand, because without knowing that, if we were to later use that value set, we wouldn't know how it was constructed. And then it comes back with the concepts that match the expansion request. So in this case, I didn't give it any parameters except the URL of the value set that I wanted to expand. So it's just come back with the codes that are in that value set. It hasn't filtered them in any way. On the other hand, this is another expansion request. So in this case, I'm asking to expand a value set whose URL is http://loink.org/vs. That is the value set for all of the codes in Loink. In this case, I've given it a filter. So I've said I want codes that match the text filter urinalysis. And I just want the first 10. Over here, I get my result. It actually says the count here is... Actually, I haven't updated my slides. I actually asked for 3 in this request based on what I got back, because the value set is actually telling me what parameters were passed into the request. So I've asked for the top 3, and I can see this has brought back the Loink concepts. In this case, it's brought back Loink parts that match that request. Another way that we can use expand is if we don't actually know which value set we're interested in, but we know which part of a resource we're interested in, then we can use, instead of using the URL parameter to tell it which value set we want, we can actually just pass the context parameter. So in this case, what I'm asking for is expand the value set, whatever value set is bound to medication.status. So the status element of the medication resource, I can just say expand that, and it'll go and look up the bindings in the structure definition, and it'll find the value set there, and it'll expand it. So in this case, it shows me that it's actually telling me what the value set is that I'm expanding. It was this medication status value set, which comes from the FHIR spec, and it's come back with the 3 statuses that are defined for that. So that's a way, if you don't need to know exactly which value set is in the binding, you can just refer to the context directly. Okay, so the second use case I'm interested in is analysis. So what often happens, particularly if we're dealing with legacy data or data that's coming in from elsewhere in a health system, is that you get a bunch of data that arrives and it's coded, but you have no idea of the quality of that because you don't know the tools that it was entered in. All you get is some dump of data. So one of the first things you want to do then is to go through the coded fields and say, show me which of these codes are actually legitimate for this field. So do I have medications in my diagnosis field? Do I have, I don't know, sort of marital status in my gender field? And the way we do that is using the validate code operation. So once again, we choose our code systems and our value sets to work out what we think are the acceptable codes for a given field. Once again, hopefully we're using standardized ones if we can. Otherwise, we might be defining our own. Once we've done that, then we can use validate code. And validate code is an operation that allows you to take a code and to take a value set and just say, is this an acceptable member of this value set? And then if we're doing analysis, we might then get into some other operations. So we might need to translate some foreign coded data that's using some other code system across to normalize it to some code system that we're expecting. And I'll get into the translate operation in a little while. And then we may use subsumes or closure or validate code to kind of categorize the data as well, but I'll get into that in a little bit as well. So the validate code operation, as I said, this takes a code and it takes a value set. And it tells you whether the code is in that value set. As a bonus feature, you can also pass it a display text for that code. And if you do that, it will tell you whether that display text is an acceptable display text for that code. So this is really useful if you have systems, without naming names, that allow you to select a code and then override the display text, which is a very dangerous thing. It allows you to pick up that case where that's happened. It can't tell you which order they did it in, whether they chose the text and then changed the code, or chose the code and then changed the text. But But it's a very useful thing to be able to do. So here's an example. This is a SNOMED example. So I'm saying validate code. I'm going to give it the URL of all of the concepts in SNOMED. So that's HTTP SNOMED info SCT FHIR VS. I'm going to use and then to tell it the code, I need to tell it a pair of a system and a code. And this is a pattern that's repeated all over FHIR. When you're using a code and it's not somewhere where you know a priori what the code system is going to be, you typically have to pass around both the URL of the code system and the code itself as a pair. So in this case, I'm saying that the system of the concept I'm passing in is SNOMED, and the code I'm passing in is this 38362.002, which is the code for dengue fever, which is important to me because I'm from North Queensland, where there's lots of dengue fever. And then if I call that on the server, then it'll come back and it'll say, yes, that code is a member of that value set, and the display is indeed dengue fever. This is a second example. So in this case, I'm actually passing a display in. So I'm saying, validate this code. The code is 13644.009, and the display text that I've received from someone is hypercholesterolemia spelt like this. So I ask my server this, and in this case it comes back and it says, no, that's not correct. The display, the code is in the value set. It gives me a message. It is in the value set, but the display term that you've provided is incorrect. And then just up above it has the correct display term, or the preferred display term, which is hypercholesterolemia with an AE. I've used the Australian version of SNOMED here. It may be different in the US edition. And certainly with SNOMED, you would hope that they're using any acceptable term for that concept. So if there were a synonym that was hypercholesterolemia without the AE, then that would be acceptable. It would still tell you the preferred term when it comes back, but it would say, yes, that's an acceptable term for that code. So another use case that is another fairly simple one is you're looking at a code system. Perhaps you're preparing to put together a value set for use in analytics or for categorization or something. And you just want to look at the set of concepts that exist and how they relate to one another. So the operations that are really interesting for this are the lookup operation on code system, and then possibly some subsumes operations as well. If we get a set of codes, we want to see how they interrelate. We want to see what the hierarchy is that exists between those codes. Subsumes can help us do that. So the lookup operation, this allows us to retrieve details about a code. So we can submit the code either as that code system pair, and if we really care about which version of the code system, we can also pass in a version, or we can pass in a coding object. So a coding object's another way that coded data is represented in FHIR, which is basically just a single object that groups those three things together. And this will tell us whether the code exists in the code system, because if we try and do a lookup on a code that doesn't exist, then we'll get a 404. And it allows us to retrieve either specific properties or designations that we're interested in, or all of them for that code. So as an example, what I'm doing here is a lookup. I've got a little code system. This is a proprietary code system that I've defined that lists all the jurisdictions in Australia. So there are 6 states and 2 territories. And I'm going to look up and say, tell me everything you know about the code WA in this code system. So I pass that in, and what I get back is a parameters object with all the information about that code. So it'll tell me that the code system's name is Australian jurisdictions, the version of the code system 0.0.1. The display text for that code that I passed in is Western Australia. It has a designation, which is a synonym, so that's the SNOMED code for synonym. So there's a synonym which is West Australia. And then it has it has a property down the bottom that says its parent is AU state. So it tells it that WA is a state as opposed to a territory in Australia. So that comes back with all the information that the terminology server knows about that code in that code system. The other operation that we want if we want to explore codes is subsumes. So subsumes allows us to explore the hierarchy relationships that may exist between codes in a code system. So this is very dependent on whether the code system has a hierarchy, meaning that actually involves subsumption. So when we define a code system, we can actually tell it, when I put hierarchy in here, it's just my own convenience. There's no actual subsumption going on. If we do that, then subsumes isn't a very useful operation to us because there will be no subsumption relationships in the code system. Alternatively, we can say, look, when I design this code system and I show nesting, that means subsumption. So that means code B is a code A. And in that case, we can use subsumes. So to use subsumes, we pass in a couple of parameters, code A and code B. And once again, we do that either as code system version or with codings. And the result will tell us one of 4 things about the relationship between the codes. Either that they're equivalent, basically the same code. That seems like a really simple thing. That seems like it would only happen if you passed in the same code as both code A and code B. But if your code system actually supports post-coordination, then it can be really useful to be able to say, I've got this code which is expressed as a post-coordinated string, and I've got this pre-coordinated code. It can be really useful to be able to know if they are actually equivalent. Alternatively, it could come back and say it subsumes, so code A subsumes code B, or it could say subsumed by, code A is subsumed by code B, or it could say there's no subsumption relationship that holds between these, so not subsumed. So as an example, this is a subsumes test with a couple of SNOMED codes. I can't actually remember what they are. Someone will know, maybe. And so I pass it in, and I ask my server, and it comes back with a very simple parameters message saying, yes, there's a subsumes relationship that holds between code A and code B. If we are interested in exploring hierarchy relationships, the other operation that's really interesting is the closure operation. So it gives you a much more powerful way to explore the hierarchy relationships amongst larger groups of codes, and to see how those relationships change when you add new elements into that group. So that's a more complex operation involving a few steps to use it. And if you're interested in learning about closure, I'd very much encourage you to go and see Rob's talk, which is this afternoon, I think, tomorrow, where he'll cover how closure works. Or come and talk to me or one of the other terminology people around. So the next use case I want to talk about is mapping. So this is really useful if we want to do things, for example, like mapping clinical codes across to billing codes. So for example, in Australia, clinically we often use SNOMED CT, but for billing purposes we often need to map that to ICD-10 AM. So we can use a concept map for that. Or perhaps we want to map legacy codes to say, I've got these old codes that were entered a long time ago. I want to be able to map those forward to what the equivalent modern codes are for the purposes of my analysis, being very careful about the meaning of that. So the first step when we want to do this kind of mapping is we either find or build a concept map. So the concept map is what expresses these relationships. Sometimes we can pick them off the shelf, so there are some concept maps that come with the SNOMED distribution, for example. Sometimes there are companies that offer maps as a service, or perhaps if we're using a proprietary code system, we'll have to build our own map. Once we've done that, then we can use the translate operation. So the translate operation is pretty simple. It allows you to, using a concept map, to translate a code across to whatever code or codes it's mapped to by the concept map. Usually this uses a specific concept map resource. Not always the case. It is possible to have the URL point off to some algorithm or heuristic that's actually performing the mapping. That's a perfectly acceptable use of the translate operation as well. Once again, we pass in a code or code system version lump to tell it what code we want to translate. We specify the target value set that we're interested in, so what do we want to map to, and what the URL of the concept map is that we're interested in. If we don't specify the URL, the server's actually at liberty to decide what it does. Most servers will look at all the concept maps they have, and it'll show you all the mappings that exist in any concept map that the server knows about. Most. But it's not part of the spec, so you should rely on that. When the results come back, they come back as a parameters object. And importantly, the parameters object will include the relationship that exists between the two codes according to the concept map. So it could say, the concept map could say, for example, code A is equivalent to code B, or it could say that code A is narrower than code B, or that it's just related in some unspecified way. There's a set of relationships that exist there. If you're designing concept maps, be very careful about which relationships that you use, because they're going to change. The number of relationships is going to shrink in the next release of FHIR. But there are some that are in there that are safe. So if you're interested in that, come and talk to me or Rob or Michael Lawley about which relationships are likely to stick around. So here's an example. This is using a concept map that exists in the SNOMED CT release. It's the replaced by reference set, which tells you for retired codes, what have they been replaced by. And what I'm asking here is to use that concept map to show me the target, show me the SNOMED codes that's mapped to. And the code I'm passing in is actually a thing called bronze diabetes, which used to be a code in SNOMED, but has since been retired, mostly because it's not diabetes. And the historical associations concept map that I'm asking here says this is equivalent to diabetes mellitus co-occurrent with and due to hemochromatosis. So if I had data that had the old bronze diabetes code in it, and I wanted to do some analysis, but only using active codes, then I could temporarily migrate that to the active code if that's appropriate for my use case, so that I could then analyze it using its replacement code. I wouldn't replace the original code, obviously. Okay, if you're doing more sophisticated analytics, then there are a bunch of ways that you can do this. So this is if you're doing things like preparing dashboards and running reports on the coded data that you're seeing flowing through your system. What you're probably going to want to do is categorize your data as one of the first things you do. And value sets are a way for you to do that. So you can design value sets that really capture the categories that you're interested in, and then you can use either validate code or subsumes or closure sometimes, but probably validate code to group the codes that you've seen into these categories so that you can visualize them in your graphs and dashboards. By far the best way to do this is with a FHIR server with terminology support, because the value sets that you tend to use for things like data entry tend to be fairly simple value sets. You often just have an enumerated list of codes. Once you start getting into analytics, you start getting into much more complex value sets, because you want to start doing rule-based value sets and things like ECL-based value sets if you're using SNOMED to build categories for codes that you may not necessarily anticipate. And that's where you really want to, like, really good terminology support. I'll just very quickly cover off a little bit about authoring terminology resources. So at a bunch of points in my presentation so far, I've said you can either pick a code system off the shelf or a value set off the shelf, or you can design your own. So this is the case where you need to design your own. And there are a bunch of cases where you might need to do this. If you're building a UI and you want to construct value sets that capture exactly which codes are acceptable in a given field, then you might need to build some value sets. If you're editing profiles or coming up with an IG, then probably you're defining bindings for the coded elements in those resources, and you need to either identify some value sets that you can bind those fields to, or maybe you need to design your own value sets that you can bind those fields to. Or perhaps you've got some proprietary or jurisdictional code systems that you need to author, or you need to design concept maps that map between those. So if you're designing a code system resource, this is kind of a very brief summary of the structure of the code system resource. Obviously the spec shows you the details, but broken down into categories, the URL and the version of the code system are really important, because that's how you identify it in all the other operations that you'll use it in later on down the track. So if you're referring to a code system while you're defining a value set, then you'll use the URL and the version. If you're doing a lookup, then you'll use the URL and the version. So those are important identifying information for the purposes of other use in FHIR. There's a whole bunch of metadata that you can specify for a code system: name, title, identifier. Identifier now has multiple values in FHIR 4, status, experimental date, etc. Those metadata fields are common across all of the terminology resources. So on the slides I'll get to in a moment for value set and concept map, same ones. There are a few fields as well that change how a code system can behave. So case sensitive tells you whether the user is required to get the case right in order for a code to be correct. Compositional tells you whether the code system supports post-coordination, basically. So for systems like SNOMED, which have a very complex and rich post-coordination syntax, or UCOM, which has quite a rich grammar-based way of determining codes, or even things like ICD, which has modifier values that can, in very specific circumstances, change or extend the meaning of a code. Those can be compositional code systems. Hierarchy meaning tells you whether there is a subsumption relationship between the codes in a code system, or other kind of hierarchical relationships between the codes in a code system. Version needed goes to what is sometimes called concept permanence. So it's whether you're always required to identify the version of the code system in order to use it. Content tells you whether the code system resource that the server has all of the codes in the code system, or some of the codes in the code system, or it currently doesn't have the codes in the code system and it's just showing you the metadata. Supplements is a very complex part of code systems that is still kind of shaking out. If you're interested in code system supplements, I won't cover them today, but please come and see me afterwards. And then count, which is the number of codes that are in the resource. The other metadata that you can define is you can describe the properties and the filters that are available on the code system. So in terms of properties, you can say what the type of the property is, what its name is, and what its URI is. And then you can define which filter operators are available for those properties, or for new filters on the code system as well. So for example, here's an extract from a code system I did for those Australian jurisdictions. So I've got a whole bunch of metadata up the top. Critically, I've got a URL there and a version. I can tell that it's an ISA hierarchy, so it does have subsumption. And then I've defined a couple of properties on it. So I've defined a capital property, which is the capital city of each of these jurisdictions, which is a string. And then I can say a neighbour property, which is a code-typed property which points off to the neighbouring jurisdictions. The other, and obviously the most important part of a code system, is the concepts that it defines. So these can be represented in a hierarchy. You can represent that hierarchy either using nesting within the JSON or XML that you're using, or you can define child and parent properties of the code explicitly. And most servers that I've seen will respect either of those. You can define the display text for a code, and then you can define any designations that apply. The FHIR spec suggests using the SNOMED CT terms for the type of designation. You're not restricted to that in terms of the use of the designation. You can also define different properties on the code system. So here's an example from my jurisdictions code system. I've got an Australia code, which is the whole of the Australian jurisdiction. I've got an Australian state, which is a part of Australia. It's probably a broken subsumption relationship there. And then I've got Western Australia as a given state, and for that I've defined a synonym, and I've defined a capital property and the neighbours properties. You might notice that not all of those properties came back when I originally did a lookup on the WA code. Lookup is not required to give you all codes by default. So out of the box, if you don't specify, lookup will show the properties for the code that the server determines are useful. If you want to see all of them, you need to tell the server which properties you want. And there is an emerging convention, I think, to support property equals star, which means show me all of the properties that you know about. The value set resource has basically the same metadata as the code system resource. So URL and version for identifying it elsewhere in FHIR. And then name, title, publisher, copyright, etc. Value sets define what codes are included in them using a series of include and exclude statements. The way these work is that the includes are processed first and then the excludes are processed afterwards. you can either, within an include or an exclude, you can either specify a whole code system just by specifying the URL and or the version of the code system, or you can say the list of codes, so you give a URL and a version for the code system and then a list of concepts, or you can define some filters, so you can say something like property equals AU state or neighbour equals Western Australia, so you just find the states that border Western Australia. Or you can combine these things. And actually there's another one I haven't included there. You can include some other value set. So you can say include anything that's in this other value set. And then you can combine those things. So if you put multiple, if you put say 2 filters inside the one exclude, they'll be ANDed together. So anything that matches must match both of those. If you put 2 filters inside separate include statements, they'll be ORed. So you can say anything that satisfies either one of those filters. So you can combine these different kinds of includes and excludes to build quite a complex definition of a value set if you choose to do so. So in this case, what I've done for my Australian mainland states value set, I've said I want to include anything that's a descendant of AU state, which is going to get rid of my territories. And then I'm going to exclude Tasmania, because we do that a lot in Australia. And that's just going to give me all the mainland states in Australia. Concept map resource. Once again, the metadata is exactly the same as it was for the other resources. And then you can build up groups. These are simple one-to-one maps that specify the source and target code in the map. Okay, the last one I'll touch on quickly is, are there any people here who build servers, build FHIR servers? Excellent. There's a lot of power in integrating your FHIR servers with a terminology server. So there are things that you want to do on a server, such as supporting terminology-aware search, or supporting full validation, including validation of terminology, where it's really useful to be able to link across to a terminology server. So for example, the first search I've got here says condition code below 732.11.009, which is diabetes, and that will find any condition whose code is diabetes or any of its descendants. Because it's not actually that useful to just search for diabetes, because there's a good chance that the clinician has selected some specific kind of diabetes under that code. Likewise in procedure, this search allows us to say, show me any procedure whose code is in the value set that I've defined as my elective procedures value set. And that's a really useful thing to be able to do on a server. It gives people who are trying to gather data from the server a lot more power in terms of being able to select which resources they're interested in. So those are examples of terminology-aware search, where if you're using complex value set definitions, then so you can implement those things on your own server, just using your own terminology support. Another option is to call out to an externalized terminology server to help you support those kinds of searches. And likewise for validation. So if you're validating a resource against a profile, and that profile binds to value sets that have complex value set definitions, then it can be useful to be able to use an externalized terminology server to handle the expansion or validation of those value sets for you. So if you're doing that, you can either just call the operations that I've described. It's very easy to implement. It's not particularly performant. Another solution is to build virtual tables if you're using a database, or whether you're using some other store that supports virtualized storage, which hits the terminology server, probably not synchronously. And that can handle caching for you. That tends to be more performant. Alternatively, you can manage local caches of value set membership, possibly using the closure operation. And again, if you're interested in that, get along to Rob's talk. That's much more efficient. It doesn't deal quite so well with dynamic value sets. So if someone posts a new value set to you, it can be more difficult. So a few things I haven't covered here. I haven't covered an awful lot of detail about how SNOMED works in FHIR. If you didn't get along to Rory's talk, please check out the video that will be up in a little while. I haven't covered details about how LOINC gets used in FHIR. If you're interested in that, please get along to Dan's talk later on today. I haven't covered closure. If you're interested in that, please get along to Rob's talk tomorrow. I haven't covered code supplements because they're really complicated and dangerous, but if you're interested in them, please come and see me. And I haven't really covered the validate method and how it works with terminology, but once again, if you're interested in that, please come and see me. Just a final quick word, a couple of tools that we produce, a couple of which are free to use. Shrimp is a terminology browser that allows you to explore the hierarchy and properties of different code systems, particularly SNOMED CT. Snapper is a terminology authoring tool that allows you to author value sets, code systems, and concept maps. And Onto Server is our terminology server. And if you're interested in that, either hit the website or just come and talk to someone with a CSIRO shirt on. OK, thank you very much. Am I running too late for questions?